Hi students, my name is Professor Marie Wong. I'm going to show you in this very short video how to do hand calculations for a single sample t-test and how to compare that with the SPSS printout of a single sample t-test. I'm not going to focus on a lot of theoretical background. I just want to show you very quickly in this video how to do the calculations. Okay, so in my situation here, what I have is I have a population mean of 10. So mu equals 10. That's my population mean for the work satisfaction in the general population. So let's say I know that the mean in the general population for work satisfaction is 10. I happen to have a sample from company XYZ where M is 12.44. So M equals 12.44, that's my sample mean. With that data from company XYZ, I also have sum of squares, which is 16.16, and my sample size, my little n, is 9. And you can see in the right-hand corner of the slide, I've written out the hypotheses that you would have for a single sample t-test. For the null hypothesis, HO, we're stating that we think there's no difference between these means. So we have mu1 minus mu2 equals 0. For the research hypotheses, the H1, we're stating we do think there's going to be a difference, that mu1 minus mu2 does not equal 0. Notice I don't specify a direction there. I'm making this a two-tailed test. So I don't know, in my hypotheses, I'm not making a case for company XYZ having higher versus lower work satisfaction. I'm simply saying that work satisfaction in company XYZ is going to be different than work satisfaction in the population. Okay. All right, so what we're going to need if we're going to do hand calculations is we're going to need to look up a critical value in the t-table. So you can find a t-table in almost any stats book, or you can even Google it. I couldn't find a t-table that I could put up here that wasn't copyright protected, so you'll have to go and look for this on your own. But what we're doing is we're going to assume, in psychology, we usually use alpha at 0.05. You can set alpha, but it's pretty much conventional that we set it at 0.05. I mentioned in the previous slide that this is a two-tailed test. And also, I want to remind you that for our sample size, when we calculate degrees of freedom, we use our sample size to do that. So in this case, degrees of freedom for a single sample t-test is going to be n minus 1. So remember I said that our sample size was 9. So n minus 1 is 8. So our degrees of freedom here are going to be 8. So I can go and find a t-table. And in the t-table, I can indicate that I'm setting alpha at 0.05. That this is a two-tailed test because of my research hypotheses. Remember, I have the does not equal sign in there, so I need to specify both the positive and the negative end of that tails, and then our degrees of freedom are going to be 8. So if you were to look that up in the t-table, the critical value you would get would be plus and minus 2.306. So if we get a t statistic, if we calculate t, and it ends up being greater than 2.306, or less than negative 2.306, then we will reject our null hypotheses. Okay, so the critical value is what we're going to use. We use that as our standard to determine if we're going to reject our null hypotheses or not. So we calculate t, we call that t observed, and then we're going to compare it to t critical, this critical value here that we get from the t-table. And again, to get this from the t-table, you would need to know, you need to have an alpha set. Typically, we set it at 0.05. You would need to know if you had a one-tailed or a two-tailed test. That's going to depend on your research hypotheses, your H1. And then you'd also need to know degrees of freedom, which is based on your sample size. Okay, so right now we're pretty much getting ready to do our calculations here. So now we're going to turn to hand calculations. So I'm going to show you these hand calculations, and they're fairly simple. We can do this in 3 simple steps. Okay, so what we're going to be doing here is we're going to calculate a single sample t-test. So the first thing we're going to want to do, there's really 3 parts to this. Let's make this part A. The first thing we're going to do in part A is we're going to determine our variance. Okay, so variance, if you remember the formula, it's going to be s squared equals sum of squares divided by n minus 1. Okay, so this is the formula for our variance. And so what I simply can do is I've already given you sum of squares with the problem. We already know n, so we can just plug this right in. So if you recall, our sum of squares was 16.16. And if you remember, our sample size is 9. So 9 minus 1, it's going to give me 8. So I'm going to have 16.16 divided by 8. And that's going to give me 2.02. Okay, so that's going to be my variance. I'm going to need the variance to calculate the standard error of the mean, which is in our next step. I'll just put this in parentheses for you so that you can remember that this is the variance. So the next thing we're going to calculate is the standard error of the mean. Okay, so to calculate this, we just need to take the variance, and we're going to divide it by the sample size, and then we take the square root. Okay, so our variance we know is 2.02. Our n here is 9, and we can't lose, we want to make sure we keep our square root sign here. So if I take 2.02 and divide it by 9, I get 0.22. I have to take the square root of that, don't forget. So when I do that, I'm going to get 0.47. Okay, so 0.47, this is my standard error of the mean. And this is going to be the bottom part of my single sample t-test. Okay, so this is basically a measure of sampling error. That's going to be the bottom part of my t-test. So to calculate t is simply going to be, the formula for t is going to be m, remember that's my sample mean, minus mu, that's my population mean, divided by the standard error of the mean. All right, so that's our formula for a single sample t-test. And what you're going to see here is, I'm just going to plug in, remember my sample mean that was given to you is 12.44. The population mean is 10. And we already calculated in part B the standard error of the mean, which is 0.47. Okay, so that's going to give me a t of 5.19. So this is my t observed. This is the t value that we calculated is 5.19. So that's my answer. That's my t. We calculated it using 3 simple steps. First, we had to take the sum of squares and the degrees of freedom. And then we use that to calculate variance, and then we plug the variance into the formula for the standard error of the mean along with the sample size. We did our calculations, and we got our standard error of the mean 0.47. That's the bottom part of our t statistic. The top part is simply comparing the sample mean and the population mean. So 5.19 is my t observed. And if you remember, we looked up in the table a critical value, right? And if you recall, the critical value was 2.306 plus and minus, right? So what we're doing is this is our cutoff. So anything that's above positive 2.306, anything that's below negative 2.306, anything in these tails we would reject our null hypotheses. Okay, so now you can see t is 5.19, so you can know t is going to be way out here, right? So we know we're going to reject our null hypotheses. So that's going to be our decision. We can reject our null, and we can do this because 5.19 is greater than 2.306. This is again, 2.306 is my cutoff at the positive end, negative 2.306 is my cutoff on the negative end. Anything in the shaded area, if we get a t observed in those shaded areas, we would reject our null hypotheses. Okay, so we've done really simple calculations here. Now I'm going to go back to my PowerPoint slides. Calculations. I want to show you how to do SPSS output. I just want to show you what this would look like if we took the exact same data and put it into SPSS. Now there are slight differences simply because of rounding error. So if you look here, my t statistic I got in SPSS is 5.15. And if you notice when we calculated, it's 5.19. That's such a small difference, it's not going to matter. So don't worry about that tiny difference. It's because of the way things were rounded. So in the blue, I've circled what t is. You can also see that degrees of freedom are 8 right there. And you can see that the significance for a two-tailed test is 0.001. So the way you can write this, like if you were reading a journal article or if you were reporting your results for a project, you would write T and then your degrees of freedom would be in parentheses. So our degrees of freedom were 8 equals 5.15. And then P is less than 0.001. So what this is telling me is, and the way I would report this, anytime that P is less than 0.05, remember we used 0.05 for our alpha level. Anytime this significance level that's reported in SPSS, if it's less than 0.05, you can call it statistically significant. There is a statistically significant difference between the population mean and the sample mean that we were examining. A couple other things I just want to show you. If you look at the mean, if you look at the top row there where it says one sample statistics, the mean is 2.44. That's the mean difference between that sample mean and the population mean. The standard error of the mean is 0.47467. So if I take the difference between the two means, which is 2.4444, and divide it by the standard error of the mean, which is 0.47467, that's where that T equals 5.150 comes from. So what's going on when we calculate a T statistic is it's basically this ratio of the difference between means and sampling error. So the difference between means, again, was just that 2.4444. The standard error of the mean represents sampling error. So it's this ratio is what we're essentially getting. And then we're locating that T observed on our T distribution, and based on where it falls on that T distribution, we will either reject our null hypotheses or we'll fail to reject it. In this case, we reject our null hypotheses because the significance level is less than 0.05. In fact, in this case, it's less than 0.001. So this has just been a basic summary, just a quick way to show you how to do a single sample t-test. There's much more that you should know in terms of background, but this is just a quick way in case you need to use this for a research project, in case you need to refresh your memory on how to do a single sample t-test or how to interpret the output in SPSS. That's what this lecture was for. Thank you.